Number 11. So number 11, you've got the figure that's on the previous slide. So, in the figure at the right, a cord runs around two massless, frictionless pulleys. A canister with a mass of 20 kilograms hangs from one pulley, and you exert a force F on the free end of the cord. A, what is the magnitude of F if you're to lift the canister at a constant speed? B, to lift the canister by 2 meters, how far do you have to pull out the free end of the cord? Okay, so this is a thing that when we did equilibrium problems, I did not spend enough time on this type of stuff. And it's a thing that I need to make sure we go back and get at the end. All right, so the problem tells us that this has a mass of, what did I just say, 20 kilograms? Or was it 50?
15.
Oh.
Wait, no.
20 kilograms.
Yep.
Oh, we're on 11.
Yeah, sorry, again, this drawing is, okay. So here we go. So 20 kilograms. So that means that the force of gravity on this thing is going to be 196 newtons, right? Just 20 times 9.8. Okay, name the force that's lifting that thing. Tension. Yes. What should I be conscious of?
There's two of them.
You have two of them, right? You got tension from this cable and tension from this cable. So what does the tension really have to be to lift it, to make our net force 0? Half of 196, right? Who said that? Does that make sense? Yes. So that's weird. How can I lift a thing that weighs 196 newtons by only using a tension of 98 newtons? Well, here's the deal. Look, suppose, so everybody got that? Like the drawing there?
Yes.
All right, so let's think about distance here. So suppose I pull the rope down a distance of, I think the problem actually gives us a number, 2 centimeters. Okay? So I'm going to pull the rope down 2 centimeters. Okay? That means that over here, this side of the rope has to decrease by a length of 2 centimeters, right? Half of it's going to come from here, half of it's going to come from here. How much is the weight going to go up? Just 1 centimeter. Okay? So look, my change in potential energy is going to be mass times 9.8 times the height I lifted, which is 1 centimeter.
That's 2 centimeters.
Seriously? Stop laughing at me!
No.
Mr. Ecker, you're lifting the canister by 2 centimeters, not.
Yeah.
Oh, am I reading the problem wrong? Is that what you're telling me there? Oh, to lift the canister by 2 centimeters.
So it's 2 and 4.
All right, so it's 2 and 4 instead of 1 and 2. Thank you. I heard you say that the first time and I didn't process it.
Yes, sir.
All right. All right, so we're going to lift this thing up 2.02 meters, right? All right, so who's got a calculator? What is that? That's going to be 0.4, so is this 3.92 joules, I think? Follow? All right, is that right numerically? Did I multiply that right? Okay, so that's our change in total energy. That's got to be the work done by non-conservative forces, right? Now, remember yesterday we had that problem where there was the block, and we ended up just doing the force that you pulled the rope with times the how much the length of the rope changed? Let's kind of do the same thing. Let's find the work that you do here. So the work that you got to do is, well, we decided that you needed the tension in the rope to be 98 newtons, right? If I want to lift this thing up 2 centimeters, how much rope do I need to pull out? 4 centimeters, right? Because of this thing about how the distance gets split. Okay, so force times displacement gives you the same answer, right? All right, so this is a thing that has been removed from the physics curriculum, and it really sucks because it's a cool thing. It's called simple machines. Okay? Simple machines work by allowing you to change the energy of an object, in other words, do work on an object, by increasing the distance you do the work over, and thus decreasing the force. That's what this pulley system is doing. It's allowing me to lift this thing up by using less force, but more distance. Okay? For a while, I had the block and tackle pulley thing over here where you could lift yourself up to the ceiling. That's how that works. You got to pull out a ton of rope to get yourself up to the ceiling,
But you don't have to pull hard.
but you don't have to pull very hard. Okay? Think about what an inclined plane does. Is it easier to lift a refrigerator onto the table or to use a ramp and slide it up to the table? Slide it, right? You're pushing it a bigger distance, but using less force, right? Okay? Gearboxes are a form of the same thing. Levers do the same thing. Okay? Screws. All right. Does all of this make sense? Questiones? All right. So, test Thursday. Tomorrow, I will talk briefly about sort of the format of the test, what I see as important concepts, that sort of thing. And like I said, unfortunately, as much as I hate to say it, we got to move on. All right. So if you've got other questions that did not get answered in class, I'm around after school today. I'm around before school in the morning. I'm around after school tomorrow. I'll be at Mr. Blue Devil if you want to ask me questions while I'm judging.
Yeah, I'm going to ask you a question from the stage, and then like show me your record about number 11.
That'd be great.
Mr. Blue Devil.